Hi, we wanted to change the way that people thought about their energy usage. Inspired by Curiosity Rover and the frustration with not knowing where all our money is going, we came up with the idea of Eco-Robot. Eco-Robot is a friendly way to make sure that your property is maximising the efficiency of its energy usage. Eco-Robot works very simply by using an Arduino robot as its basis. The Arduino robot comes with a whole bunch of functions already built in, including wheels and compass selection, which were really useful to us. We then included a number of ultrasonic sensors in a circular format around the top of the device, which enabled us to give the robot a kind of vision based on ultrasonics. We then used environment sensors on the board to detect light, gas readings, temperature, airflow, anything we could get our hands on to enable us to get more data. All of that is coordinated by a brain, an architectural brain that is enabled to think. And by thinking, I mean it takes data from its environment and its surroundings based on the location it's currently in, and also the environment sensors that it has. And it puts that together to make decisions. Rob's going to talk to you more about the architecture. The data we store from that is then put into the cloud. We use a very simple data format so we can get it off the robot as quickly as possible. And we do that using Wi-Fi. Once the data is off the system, in the cloud, we can then build and use a web-based front end to enable us to give us real-time analytics data of what the robot sees, where it is and what it's doing and what its current state is.
At the heart of Eco is essentially a electronic brain. Eco is an autonomous agent, in effect, or semi-autonomous agent. The brain has to make decisions about how to move around the environment that it's placed in, and it does this by asserting facts about the world and building a map of beliefs. Those beliefs can be things like, what is the current temperature in this location, or how far away am I from another object. From these beliefs, it can then forward chain a decision about which will result in an action. That action might be to move forward, to turn left, to turn right, to stop, or we can employ a distinct strategy. A strategy can be something we can plug in, and it tends to work by activating a yield function. What the yield function does is it takes the belief map, processes the data within there, or the facts about the environment, and calculates the area with the highest yield that we would want Eco to move to next. So it can do this based on sensor input. So for example, if we wanted Eco to move to the coldest position in its belief map, we could do that. So the coldest temperature would be the area with the highest yield. Alternatively, it could be something like the area with the highest humidity, for example.
One of the major challenges we had when building Eco was that we didn't have enough processing power available to us on the Arduino robot to do what we wanted to achieve. Namely, for him to drive around, to pick up all the sensors and to send that data via Wi-Fi, as well as making decisions about its environment and working out what to do next. The way that we overcame this was to put different processing onto separate Arduino chips and then use a bridge which then spoke in turn to each one of those and passed data among them using the SPI bus.
So when we designed Eco, we wanted to make it as portable as possible, whether that's so it can work in the cloud, on your home local network, or even on your laptop. When we played with Eco, we found that it was almost 100 operations per second. So we thought that would create a UDP stream working on Node.js as an open source module, which would allow you to create your own open source frameworks and interfaces for Eco to run on.
Eco has all the sensors on it collecting all the data, and what we wanted to do is display this in real time on the web. So we used Angular and Node and also used WebSockets to push this information straight to our interface. We record light data, we record carbon data, we also record things like temperature data. So we have the temperature, you can actually see the temperature going up and down, but also we actually store it on a graph, up to 20 readings, so you can actually see it kind of throughout the day going along.
Thanks for watching. I hope you enjoyed our video.